Find the center of mass of the uniform lamina O, A, B, C, D, E, F. So we have uniform lamina O, A, B, C, D, E, F. And we can see from the figure, okay, the given lamina O, A, B, C, D, E, F is a composite lamina. So I'm writing in this way, okay. It is composite lamina. You can see this composite lamina, okay, is made from two different uniform lamina, okay. So I'm writing this, okay. It is made from two different uniform lamina. So I'm writing in this way. One is O, A, D, E, F, and another is A, B, C, D. So we have this. Now, we need to first locate the axis of symmetry of uniform lamina O, A, D, E, F and A, B, C, D. Okay. So what we do? So I'm writing over here. First, we locate the axis of symmetry, okay, of the lamina, okay, or I'm writing in this way, uniform lamina OA, D, EF and AB, CD. So we have this. And what we find is that, okay, the mass is equally distributed, okay, for uniform lamina is equally distributed about the axis of symmetry. So we have this, and we find, okay, the center of mass, so I'm writing in this way, CM, lies somewhere, okay, it lies somewhere on the axis of symmetry. So this is to be noted, okay. So when we have uniform lamina, okay, first we locate its axis of symmetry or line of symmetry. So what we find for uniform lamina, okay, the mass is equally distributed about the axis of symmetry and center of mass lies somewhere, okay, it lies somewhere on the axis of symmetry. Now let us consider this lamina, okay, at first. So we are taking lamina, okay, for uniform lamina O, A, D, E, F, and this is a square lamina, okay. We can see the width and height is equal in magnitude, okay. So what we find? So as I said earlier, we determine or we find the position of axis of symmetry. Now, in order to find the axis of symmetry, okay, what we do? So this is the midpoint. So I'm taking, okay, roughly, this is the midpoint of the side OF. So this length is twice A, okay. So this distance is twice A. And this point, let us take this point, okay. So this is the midpoint of OA, and this distance is twice A. Now, let us draw a vertical line, okay, from this point. So in this way, I'm drawing a vertical line. So again, this distance is twice A, okay. So we have this, and let us draw a horizontal line and this way. So what we find is that these two dotted lines, okay, are called axis of symmetry. So they intersect at this point. Okay, so they intersect at this point, and this point is called, okay, it is called the geometric center. It is called the geometric center or geometrical center of this square lamina. Geometric center of this square lamina. Clear? So we have this. And for uniform lamina, okay, the center of mass coincide or lies at its geometrical or geometric center. So this is to be noted, okay. So I'm writing for, so let me write over here. For uniform lamina, this is to be noted, okay. Lamina, its CM, that is center of mass, lies or coincide, okay. So let me write in very short, okay. Lies at its geometrical center. So this is to be noted. So we find the center of mass, okay, of this square lamina lies at this point. Now let us find its coordinate, okay. We need to find the coordinate of the center of mass, okay. So what do you find? So its coordinate is 2a, that is x coordinate is 2a and y coordinate is 2a. So the coordinate is 2a comma 2a. So we have this. Clear? And before carrying this numerical problem, okay, what we do is that, okay, for each part of lamina, okay, so we see this is one part, this is another part, and they are combined to form a composite lamina. Each part of the lamina, we find or we use this concept, okay, mass of lamina equals area times mass per unit area. And let us denote this quantity by the symbol rho. So we use this concept. Therefore, mass of each part of the lamina m equals area of the each part of the lamina times rho. Clear? So we have this. So we use this concept. Clear? So I'm writing over here. Let rho, okay. This is mass per unit area of the uniform lamina, that is composite lamina O, A, B, C, D, E, F. Okay. And let the center of mass. Okay. So we need to find the center of mass. Center of, let the center, or let me write in this way. Okay. First, let X bar, comma Y bar, okay, be the coordinate. This is actually a coordinate, or it is the position. It gives the position, okay, be the coordinate of the center of mass of lamina O, A, B, C, D, E, F. So we have this. Okay, we have this. So we have this. So this is to be noted, okay? Clear? Now what we do, let us come to this, okay? For this lamina, okay, what we find, we need to find its mass, okay? We need to find its mass. So mass. So let me write in this way, let mass of lamina OAD EF equals M. Sorry, M. So we have this. Therefore, M equals, so we use this relation. Okay. We use this relation. Area. And what is the area? Okay. So let me write in this way. Area of OAD EF times rho. And keep in mind, this rho is constant. Okay. It is constant. Throughout the composite lamina, its value is constant. So we have this. Therefore, we can write M equals, and what is the area of this lamina? Its area is 4A times 4A, okay? And we have rho. Therefore, mass M equals 16A square rho. So we have this. And let us write in this way, okay? Its center of mass. So it is at this point, okay? So its center of mass is 2A, comma 2A. So we have this. Okay? So we have this. So we have this. Now, we go for lamina, that is uniform lamina, A, B, C, D. Okay. Now, I had made this figure, okay, earlier for uniform lamina A, B, C, D, okay, and we find, okay, it is a square lamina. It is a square lamina, okay, having width twice A and height twice A. So what we do, as we did earlier, we need to find or locate. First, we need to locate its axis of symmetry, okay, and we see this length AB is twice A. So let the midpoint of AB be this, okay, and this distance is A, okay, and let the midpoint of BC be at this position. So this distance is A, okay, this distance is A. So let us draw a horizontal line in this way, okay, and vertical line in this way. So these two lines, okay, represent the axis of symmetry. Axis of symmetry, and they intersect at this point, okay. So this represent the center of mass, and the coordinate of center of mass is, okay, so let me write over here, its coordinate is A and A, okay. See, we need to travel A distance along x-axis and A distance vertically up along y-axis. So the coordinate is A comma A. Right? So we have this. Now, what we do, as I said earlier, we use this formula, okay? Mass of this lamina, okay? This equals area, its area times rho. So we use this concept, okay? Now, I'm writing late the mass of lamina ABCD equals m dash, okay? We have used m for this lamina. Now, m dash equals area of ABCD times rho, and the area, okay, the area of this square lamina. So what is its area? Its area is 2A times 2A. So this gives me 4A square, okay. So this is the area. Therefore, we write 4A square times rho. So we have this, okay. So we have m dash equals 4A square rho. Now the center of mass, okay, its center of mass is at position, or the coordinate of the center of mass for this square lamina is A comma A. So we have this. Okay, we have this. Now, what we do, okay, next is that to find center of mass of composite lamina O, A, B, C, D, E, F, okay. We use the formula summation Mn Xn, okay, equals X bar, okay, the X coordinate of center of mass of composite lamina, sorry, summation mn, okay. And we can see we have x and y axis, okay. So for y coordinate, okay, or for y axis, we have this y bar, the y coordinate of center of mass of composite lamina, and we have summation mn. Let's call it equation 1, and this is equation 2. So we have this, okay, we have this. Now what we do is that, okay, we have this m equals 16a square rho, okay. So for this, so we have m equals 16a square rho, and center of mass, okay, is at its geometrical center, and the coordinate is 2a comma 2a. So we can see the composite lamina is made from two uniform lamina, okay. So there are two masses here, one m and another m dash, okay. Its mass is m dash, m dash, this is the mass, okay, and m dash is 4a square rho. So two masses m and m dash are combined to form a composite lamina, okay. So we use 1, okay. So I'm writing now from 1 we take this, okay. First, its mass is 16a square rho, and what is xn? We can see the center of mass, okay, is at this distance from O. So this distance is twice A, okay. We are finding center of mass from point O, clear? So xn is twice A for this lamina, plus now for this lamina, okay, mass is m dash, and m dash is 4a square rho, and the center of mass for this lamina, okay, is at this distance from O. So this distance is 5a, 4a, and this distance is a. It is 5a. So we have 5a. This whole equals x bar and total mass, okay, sum over mn, that is total mass, and sum over mn is m plus m dash. So this gives 16a square rho plus 4a square rho. So this is 20a square rho. So I'm writing directly, okay, 20a square rho. So let us simplify. 32a cube rho plus 20 a cube, okay. So we have 20 a cube rho equals 20 a square rho times x bar. So this gives me 52 a cube rho equals, so I'm writing in this way, okay, x bar. So let me write directly, okay. So we have this on simplification, okay, we have this, click. So this cancels out, this also cancels out. So we have 52a by 20, and we can simplify it further, okay. we have 4 times 5 equals 20 and 4 times 13. Okay, so we have this. So therefore, we have 13a by 5. Therefore, the x coordinate of center of mass, okay, is 13a by 5. So let us call it equation 3. So we have this. Now, we find y bar, that is y coordinate of the center of mass of the composite lamina. Okay, so we use equation 2. So I am rewriting equation 2 again. Summation mn yn equals y bar summation mn. So this is equation 2. So using 2. Now we know, okay, we have calculated mass of this part of the lamina is m, and m equals 16a square rho, and mass of this part of the lamina is m dash, and this is 4a square rho, and the center of mass is at its geometrical center, and the coordinate of center of mass is twice a comma twice a, and the center of mass of this lamina is at its geometrical center, and its coordinate is a comma a. So we have this, and we are finding center of mass, okay, from the origin O. So this is very important point to be noted, okay. Clear? Now what we do, so let us use this equation, okay. So we first take this lamina. So mn is 16a square rho, okay, 16a square rho. And what is yn? What we find, center of mass of this lamina is at this height, or is at this distance from the origin O, and this distance is twice a, okay. So we have this, so yn is twice a plus, okay. Now for this lamina, clear? What we find, center of mass is at this height, okay. It is at this height, is at this height from the origin O, and this distance or height is a. It is a. Clear? So we need to note this, okay. And mass of this part of the lamina is 4a square rho times y, okay, yn is a. Clear? So we have this equals y bar, and what is total mass? Okay, we need to add m and m dash, so we get 20a square rho. Now let us simplify, okay. 32a cube rho plus 4a cube rho equals 20a square rho y bar, okay. We have this. Therefore, y bar equals 36 a cube rho divided by 20 a square rho. Let us simplify the expression, okay. So we have this, okay. We are getting this. Therefore, y dash equals 9a by 5. So we can write the center of mass of the uniform lamina, okay? O, A, B, C, D, E, F is at, or we can write in this way, y dash. Therefore, we can write in this way, okay? We know x bar is 13a by 5, comma 9a by 5. So this is the final result, okay? And let us understand this problem, okay, in this way also. So I'm making a box. Center of mass, x coordinate, y coordinate, okay, mx. So I'm writing in this way, mx, my, okay. So we have this. Now what do you find? We have two portion, okay, or two parts. They are combined to form a single composite lamina. So I'm using this, okay, plus. So we have lamina O, A, D, E, F. O, A, D, E, F plus indicates the portion or part to be added, okay. So this is what we find from the figure, okay. So what is its mass? Its mass is 16 a square root, and its x coordinate is, okay, 2a. Its y coordinate is 2a. And what is mx? See, we need to multiply this to what is my. We need to multiply this with the y coordinate. So mx is, I'm writing in this way, okay, 16a square root times 2a. So we can write directly after doing the simplification also. And what is my? 16a square root times 2a. So we have this, okay. Now the next part to be added, okay, to form a composite lamina is plus a, b, c, d, okay. So we have this, and its mass is 4a square root. So we have this, and what is its x coordinate? X coordinate is a, y coordinate is a. We can see from the figure, okay, center of mass is having coordinate a comma a. So let us multiply this two, okay, to get mx. So we have 4a square row times a. Now next, we need to multiply mass and y coordinate, okay. So we have 4a square row times a. So we have this. Now if we add these two parts, then we get the composite or total lamina, okay. So I'm writing in this way. So we have O, A, B, C, D, E, F, which is a composite lamina. So this table, okay, is very useful in understanding the problem more precisely, okay. And what is the total mass of this lamina? So we need to add these two mass. So we have done it earlier, okay. We have added m and m dash. So we get 20 a square rho. Now, what is this, okay? This gives us the x coordinate, okay? Coordinate of center of mass. So the x coordinate of center of mass. So it is x bar, okay? This is the x coordinate for this lamina, okay? It is the x coordinate of center of mass for this lamina. And this is x coordinate of the center of mass for this lamina, okay? So this is what? This is the y coordinate of center of mass for each parts of the, or each part of the composite lamina. And what we can see, okay, that when we add these two terms, okay, let's go back to this slide, okay. See, we are adding these two terms. So what we get when we add it, what we get? We get this, okay. So this equals 20 a square row times x bar. So we have this. Now, when we add, okay, this two term, you can see, when we add this two term, okay, we need to add, okay, because we are adding portion O, A, D, E, F and portion A, B, C, D to get the composite lamina, that is total lamina, okay. So we need to add these two terms. So when we add these two terms, we get this, okay, we get this. So I'm writing, we get 20 a square row times y bar. So we get this. So in this way, we can tabulate, okay, the whole problem